everyone, this video is going to show you how to use Excel to calculate binomial distribution probabilities and what those calculations mean. So we're going to use problem 5.50 at the end of chapter 5 to explain this. So that problem says that the CDC estimates that 43% of Americans received a flu shot during the winter of 2016 to 2017. And a random sample of 7 Americans were selected. So, number of people is what we've got over here, 0 to 7. So what we're trying to figure out is if 43% of Americans got the flu shot, what's the probability that 2 out of the 7, exactly 2 out of the 7 had the flu shot? Or what's the probability that 5 or less got the flu shot? Or what's the probability that all 7 got the flu shot? So that's what we're trying to figure out. So what we're going to do is we can either use that function builder and we can search for our binomial distribution. So binom.dist. And you can insert the function and use the formula builder over here. If you look down here, it tells us exactly what pieces this formula needs. It needs the number of successes in the trials, the number of independent trials, the probability of success, and then is it cumulative? So are we looking at the overall probability or the probability of that trial number or successful trials? So I'm not going to use the formula builder. I'm just going to type it in. So equals binomial distribution and number. So the trial that we're looking at is 0. So this one will tell us, again, what's the probability that exactly 0 of these 7 had the flu shot? Total number of trials is going to be 7 because we're only sampling 7 people. The probability is 43%, so 0.43. And then cumulative, we do not want this one to be cumulative, so we're going to put false. And we close our parentheses and hit return or enter. And we'll see that if we asked 7 random people, it would have about a 2% chance that exactly 0 of them would have gotten the flu shot. And so then we just drag that down. And you can now answer question A. What's the probability that exactly 4 people from this sample received a flu, if I could spell flu, shot? Well, if we look, exactly 4 people, so if we sample 7, what's the probability that 4 people will have gotten it? Exactly 4? It's about 22%, or 0.221. So we'll say 0.221, or 0.2216. What's the probability that more than 2 people from this sample received a flu shot? I don't know why it wants to keep changing my spelling, or maybe I just can't spell. So more than 2. So we need to take the sum of B5 through B9. So we're going to type in equals sum, and then we'll come over. So we want to know more than 2 people. B5 through B9. Close up those parentheses. And there's about a 64.4% chance that more than 2 people will have received the flu shot from this sample. What about the probability that we'll get 3 or 4? So that's just adding 3, so B5 plus B6, 3 or 4. About 51%, or 52 if you round it. So now we want to know what's the probability that the number of people, I apologize, you can tell that I did this kind of quick, people that received the flu shot was 5 or less. So we could come in here and sum up all of those. This is where the cumulative part comes through. So we're going to do that exact same formula, except for we're going to put true at the end. So equals the binomial distribution. And again, we want to start with our number. Our total trials is 7. The probability is 0.43. And this time we want True, because we want it to be cumulative. Close the parenthesis and hit enter or return. This first one should always be the same, cumulative or not. And then once you drag it down, it will add all of the previous ones together. So if we want to know the probability that the number of people that received the flu shot was 5 or less, we're going to see that it's going to be 98% or 97%, so that 0.972. So about 97, we have a 97% chance that we're going to get 5, 4, 3, 2, or 1, or 0. So next we need to calculate the standard deviation for this distribution and the mean. So if we look at mean, we're going to find that we are looking at the number of trials times our probability. So the mean, we know our number of trials was 7 people. So that's just going to be equal to equals 7 times our probability of 0.43 or 43%. And we get 3.01. So now our standard deviation is equal to our square root of the number of trials times the probability of success times the probability of failure. So what that means is we're going to take our equals and we're going to find that square root function, so that SQRT, and we're going to take the square root, again, of the number of trials, so 7, times our probability of success, so the probability of someone having the flu shot was 43%, so 0.43, times the probability of failure, which would be the rest of that percentage. So if it was 43%, we take 100 or 1 minus 4.43, and you should come up with 0.57 or 57%. Close your parentheses, hit enter, and our standard deviation is then 1.309 or 1.31. And that is how you would find the standard deviation, the mean, and then your binomial distributions, and exactly what type of problems and you can answer with that binomial distribution probability.